let's get started with 1.6, applications. And of course, in this unit, we're just looking at addition and subtraction for now. There is some need to look at equals because we're going to see some word problems where maybe we need an equal sign in there, right? Especially when we look back at 1.5 where we were dealing with fact families. So here's our objective: translate phrases into mathematical symbols and simplify. And simplify just means that we want the final answer on that, okay? So if it said, what's the sum of 5 and 3? The simplified version of that would be 8. So we do need to be able to translate these, okay? So change an English phrase into mathematical numbers and symbols using keywords and phrases. Here's some of our keywords and phrases. For addition, we got sum, plus, added to, more than, increased by. Sometimes it's said that it's combined with, okay? That would also indicate addition. I don't think we'll see any of that tonight, but just so you know in the future, you may. Subtraction would be difference, right? That's the result or the total of a subtraction problem. Minus, subtracted from, less than, and decreased by. Now, two of these that I want to point out is subtracted from and less than, okay? When you see subtracted from or less than, it actually reverses the order, and I think we'll see examples of that on the next slide. Now, it's kind of indicating with these asterisks with the addition that order would matter, but we already know that, at least from the 1.5, right, properties, is that with addition, actually, order does not matter. So while these are kind of saying there's a condition that goes with these, because we know we're actually able to, and we should know that we can, change the order of addition, the order shouldn't matter. So I'm going to take away those asterisks, but it will matter for subtraction, right? Order does matter with subtraction. And then we got equals, of course, yeah, equals, that's pretty direct there. Is, that's a good word for equals, and sometimes it's missed because it's kind of a common and small word. Then yields, results in, or same as, that kind of thing. So when we see these types of words, again, we need to be able to know how to translate these into math statements or symbols. So there we go, translating, solving, adding, and subtracting. Okay, so yeah, this one's good because we got the asterisk for subtracted from and less than, right? So, think about it like this. If I said 5 less than 7 means 7 minus 5. So it's kind of like it changes the order, right? Usually students would say, well, 5 less than 7, that's 5 minus 7. Well, it's not 5 minus 7 because you got to have the 7 first and then take 5 less than that, which is why it's actually 7 minus 5. Now, more directly, 5 minus 7 would mean 5 minus 7, okay? Or, again, this one down here would be, if we kind of related it to this one, it's 7 subtracted from 5. So when you see these two types of statements, subtracted from or less than, it kind of reverses the order here. And for the most part in the past, money seems to be a good example of this. Like if I said $10 subtracted from $20, right? In fact, we can put those numbers in there. $10 subtracted from $20. Well, let's make it a little bit more different there. I said $10 subtracted from $25. Now, without having to show the actual math statement, some of you would know that that would be then $15, right? Because in your mind, you did 25 minus 10, which is 15, okay? So that's why, and again, maybe this is a good example for you. If we think about it in terms of money, but that's why that works. So it's the same thing if I use less than, and again, if I looked at money, it seems to be a little bit more applicable. So if I said $3 less than $10, again, in your mind, I think you'd make that connection a little bit better. You'd say, okay, I'd have my $10, then $3 less than that would then be $7, okay? So those two statements, I'm spending more time on these two because they are different. They're not as direct in translation as these other statements are. So let's look at this first example, translate and then simplify. So on the homework, if we saw an example like this, we would expect there to be two boxes, right? One for the translation, one for the simplification, all right? So we're going to translate it first, though. What is the difference of 913 and 601? Well, let's identify the operation first. It's a difference. Difference is subtraction, right? We can even find it in the table there. So I'm going to put subtraction, and it should be subtraction between two numbers. Now, these are just blanks that I'm filling in right here. Okay, and what are the two numbers that it gives us? Well, the first one was 913, so that should be the first number in this subtraction problem, 913. And then the second number, 601. So that's our second number because it was the second one listed. So I have the difference of 913 and 601. Just to clean this up, I can take away the blanks right here. And that would be the translation right there. So this is kind of the box that you'll be putting in, or the stuff you'd be putting into that box if it asks for a translation in the homework. Now we need to solve it, which would be the simplification. So I'm going to line these up, 913 and then 601. And yeah, we're going to subtract these, and whatever the result is the difference. So 3 minus 1, again, we're starting the ones place value. I got 3 minus 1 there. So 3 take away 1, and again, if you're using your fingers, that's okay. 1 minus 0 in the tens place value, that's 1. And then in the hundreds place value, 9 minus 6, so 9 fingers up, 6 fingers down. I got 3 fingers up there. And this, 312, would be the difference. So let's say, well, the actual difference of 913 and 601 is 312. But again, I'm just emphasizing this would be the translation. This would be the direct translation there. Now that's our first example of these word type problems. And I don't want you to get too anxious or depressed about these word problems. I know in the past students have shown a lot of disdain for these, and probably rightfully so, but what I would encourage you to do is just take your time with these, all right? Just kind of plan on them taking some or a lot of time. So when you're in or part of your 12 hours of study outside of class, or was it 16? This may consume a lot of that time, all right? Just translating these. And I read this once, but you kind of notice that I in between the problem, I also read it 2 or 3 times, okay? All right, we looked at difference, we looked at the two numbers, their order, and how it affected or placed in the operation, which in this case is subtraction. So plan on that taking some time if you feel like you struggle with these. If you hate them, it just may double the time, all right? Now let's look at this one as well. Translate and then simplify, right? What number do you get when you subtract 123 from 235? So I think this one is even worded just a little bit different, right? It says subtracted from up here, but this one says subtract this number from. So it's kind of put the number in between the subtracted and the from word right there, if we look at our table anyways. So since it is that way, it means that it needs to be subtracted from a number. Well, subtract, okay, we know subtract, that's subtraction, and that's good. And we should only be subtracting 2 numbers right now. But what 2 numbers are we subtracting? Well, it says that it's 123 subtracted from. Okay, that means that we've got to take the first number, or we're taking the 123 out of it, which means that the 123 is the second value. So whatever number we start with, we're going to take out of that or from it 123. Well, what number are we taking the 123 from? It's the 235. So yeah, as a math sentence or a math statement, this would be 235 minus 123. It means exactly the same thing as subtract 123 from 235. It's the exact same thing. So we've got this set up, and again, it may be a box in the homework that you have to put this into. Let's go ahead and simplify this. Okay, so it is subtraction. I've got 235. I'll give myself more space there. There we go. 235 minus 123. Well, we haven't seen any borrowing yet. I assume we will eventually, but I forget. So in the ones place value, I have my 5 minus 3, so 5 fingers up, 3 fingers down. I get 2 fingers up. I almost put 2 fingers down, but I kept it to 3. So that's the ones place value. Now the tens place value, right? 3 minus 2, so 3 fingers up, 2 fingers down. It's 1 finger up. And now the hundreds place value, I've got 2 fingers up, take away 1 finger, boom, I got 1 finger there. So the actual difference, or the final answer here, the simplified answer is 112. Whereas the translation is 235 minus 123. So translate and simplify this one as well. What number increased by 72 gives you 136? So the first thing, again, I would be looking at here is what operation are we dealing with? Well, it's increased. Okay, increased indicates addition. Now up here it says increased by. Well, I guess it says increased by as well, but just the word increase should indicate addition, whether you include the word by with it or not. Okay, so we're increasing numbers. Well, we're increasing what number to what other number, or what 2 numbers are we dealing with? So again, I've got 2 blanks here. I'll fill in. So what number increased by 72? Okay, so we're going to take a number. What number increased by 72? And this is going to give us 136. Well, the last couple have been more direct. This one now, it says it gives you 136, right? So some number increased by 7. So something plus 72 gives us 136, which means, and it's not actually in the list of equals. This gives you business, right? It's not up here. But that gives you means that it's going to equal whatever that number is, which, of course, is the 136. Okay, so we're going to take some number. We're going to start with that number, and then we're going to increase it by 72. So that's what's going to go into the second blank right here, the 72. And again, this is the first time we've seen an equal sign in the translation. And now we're solving, again, this is like the fact family stuff where we have to solve for this unknown right here. Now, that's the translation. We still need to solve for the blank right there, right? What number? That's what we're actually simplifying this to. Well, if I use a fact family, what I would do is I would take the 136, that's the sum, and I would subtract whatever number was being added, which in this case is 72. And I could subtract the number here if this was the number that we knew and this was the blank. So it's going to work the same way, and then this is going to equal the number right there. So I changed it into a subtraction problem because now I'm working directly with those 2 values. So I'm going to take those 2 values, 136, and I'm going to subtract 72. And what does this give us here? 6 minus 2, so 6 fingers up, 2 fingers down, it's 4 fingers up. And then in the tens place, here we go. We got some borrowing. It's 13 minus 7, right? Because I got to borrow from the 100. Okay, now that 0 in the hundreds place value now just indicates that pretty much all the hundreds are gone, right? Because we didn't have any zeros in the purple number there either. So I really have 13 minus 7. So 3 fingers up, 7 fingers down, I get 6. So our final answer here is 64. Or in other words, the number. What number are we talking about? Yeah, it's 64. And that would be simplified. Translate and simplify. 80 added to what number gives you 164. All right, so it's 80 added to. Now, again, up here it's indicating that it would be the number plus 80. But again, because it's addition, it's not actually going to make a difference. So I'd say I got 80, right? I'm going to start with the 80. It's going to add 2. So that's an addition problem, right? Added 2. And yeah, it is listed here, but again, if you did change the order, it's not going to make a difference. Added to, well, some number. To what number? I guess I should say we need the gives part there. So 80 added to what number? So I'll just put a blank in here, just so I know I'm going to fill that in, right? And it gives you, so that's an equals. Again, I know that's not in the equals table here, but it gives us, indicates that it would be some value, which in this case is 164. All right, so this sets up a problem at like a fact family, right? Where we would be looking for a way to operate directly with 164 and 80 in order to solve for this unknown value. So the fact family would indicate that you take the sum, which is 164, and we're going to subtract either one of the two added values, which in this case, the only one we have is 80, would work, and that would equal then our unknown value. All right, so I'll fill in this blank. I'll figure out 164 minus 80, and then that will tell me what goes in the blank. So let's go and do this. 164, and I'm subtracting 80, and that's just fact family stuff right there. And I'd say, okay, I got a 4 minus 0 in my ones place value, that's a 4. And in my tens place value, 6 minus 8, but again, the 8's not big enough, so I will have to borrow from the hundreds place value. So that 1 now becomes a 0. And again, I'm just going to scratch that out so we don't have to think about it or look at it. Maybe that's kind of mean. But 16 minus 8, so 6 fingers up, 8 fingers down, 1, 2, 3, 4, 5, 6, 7, 8. I got 8. I did it on my finger. So that's 84, which means 80 plus 84 equals 164, right? This value goes here, but it came from this fact family, which was right here. Now, again, you could check. You could say, well, I want to just make sure, like if I was taking a test or doing a quiz or something like that, just make sure 84 plus 80, does that actually equal 164? And yeah, we'd see in the ones place value, 4 plus 0 is 4, and then 8 plus 8 is 16 there, which makes up 164. So that checks off that 84 actually was the answer. And I think just doing that, I know it didn't take us too long, and it may take you a little bit longer. I hope that's okay because, again, on a test or a quiz where you would want to just know that you have an answer correct, taking this step right here, whether you show it or not on paper is a whole different matter. But as long as you do it, hopefully it makes sense to you, and then you can confirm that your answer is correct, which, again, I think it's pretty crucial on a test or a quiz. All right, if from 605 you subtract 311, what number do you get as your answer? And, I just read that out loud, and in my mind, it's, I'm trying to piece this together, right? Because it's using the word from, which to me is kind of a trigger, right? It's like, oh, okay, what's going on here? It's got the from word on there, right? We're subtracting from, which usually indicates that it's reverse the order, but it's saying we're subtracting from 605, which means that we would have to start with the 605. Start out with the 605 and then subtract from it. Okay, so that's why this one is, I guess it's kind of more direct. Okay. Now you may be able to conclude, well, it has to be 605 minus 311 because just based on the wording, right? We know they're together. They're going to be subtracted one from another. And since we haven't covered negatives, it should not be 311 minus 605. And that's a reasonable conclusion. That's extraordinarily logical, actually. So if you were able to think that way, I'd say that's actually even a higher level thinking than what we're doing right here. So if you've made that conclusion, I'd say that's a good way to go about it. But yeah, we are subtracting from the 605, 311. Okay, so again, as a more mathematical direct translation, I would say this is 605 minus 311. But yeah, we did take it from the wording that was given to us right there. So what number do you get as your answer? Well, this is just a straight subtraction problem right here. So I'm going to take 605, and I will subtract 311. And just like we've been doing, we'll start in the ones place value, 5 minus 1 there. 5 minus 1 is 4. And in the tens place value, I have a 0, which is not big enough to take 1 away from. So I have to borrow 1 of those hundreds from the 6 to make it a 5. And now I have 10 of the tens. So now it's 10 minus 1, which is 9. And in the hundreds place value, 5 minus 3, again, whether you're using fingers or however you're doing it, 5 minus 3 is 2. So that would be the difference between 605 and 311. It is 294. So what is the sum of 52 and 17? Now, sum is addition, right? We know sum is an addition problem between two numbers, and it tells us what the two numbers are, 52 and 17, right? I got 52 and 17. Now, again, the nice thing about this is when you're dealing with addition, the order doesn't matter. Okay, now if they said, it's the result is some number, okay, then where they're placed in terms of the equal sign would matter, right? That would be important, like the example we've seen. But where we're just adding these two numbers, the order does not matter. So I'm just going to take the 52 and add 17. All right, which means I can take the two numbers and just add them. I'm going to stack them, right, just like we've been learning in this unit. 52 plus 17. And our sum, 2 plus 7, so 2 fingers up, 7 more fingers. 1, 2, 3, 4, 5, 6, 7. Got 9 fingers up there. And then next up in my tens place value, I got 5 fingers up, add another finger, there's 6. So 52 plus 17 is 69. And there is our sum. I like that one. I like this one. It was a little bit more direct. At least for me, there's not as much analysis that we have to do in order to set this one up or solve it for that matter. But again, I'm going to point this out. If it does take you a little bit longer to translate these, I would imagine that translating them will take more time than the actual solving part. But once you get them set up, hopefully you can solve them, because we've been doing all this addition and subtraction stuff so far. But the analysis part, right? Reading it, rereading it, thinking about what operation you're using, how it relates to the numbers or values that are given, or even if it includes an equal sign, right? And then there may be more analysis with the fact family stuff. So Fly Airline has 40 passengers on board when it left JFK Airport in New York on its way to Salt Lake City Airport. The plane stopped in Chicago and picked up some more passengers. Then it flew directly to Salt Lake City Airport. If there were 58 passengers on board when it arrived at Salt Lake City Airport in Utah, how many passengers did it pick up in Chicago? All right, now, this one's not asking for a translation, so some of you would know exactly what to do at this point, and you could solve for it very quickly. And that would be fine. Okay, I'm going to do a little bit more analysis than that, okay? So we have a flight. It's from New York to Salt Lake. But we see that there's a stop in Chicago, right? So it's going from New York to Salt Lake. That's the final destination though, right? Salt Lake. So I'm going to start in New York. We're going to finally end up in Salt Lake. But somewhere between there is Chicago, right? I feel like CHI should be good enough for Chicago. I don't know that CH does, but either way. Okay, so it says it had 40 passengers on board when it left New York. So that means when it started in New York, boom, you had 40 passengers right there. Now, it's going to pick up some passengers in Chicago, but I don't know what that value is. So I'm going to show it with a blank. And those passengers were added to the people that were already on board. So I'm going to show it as addition. And I guess the addition kind of goes along with how much was picked up in Chicago, right? Well, the result, which is our equal sign, is however many passengers there were when it arrived in Salt Lake, which in this case is, it says it's 58 passengers there. So this is how this sets up, which again creates a fact family type problem for us to solve. And the fact family on this one would show the subtraction problem would be the sum, which is 58. And then from here, I would subtract. Again, I would just look at either one of those two values, and the one that's given is 40. So it ends up being 58 minus 40. This will tell us how many passengers were picked up in Chicago. So we'll set this up. 58 minus 40. And whatever our difference is here is however many passengers were picked up in Chicago. So 8 minus 0 there, and our ones place value is 8. And then 5 minus 4, 5 fingers up, 4 fingers down is 1. In the tens place value, of course. So 58 minus 40 is 18. So 40 plus 18 is 58, and that would check off. So that means that they picked up 40 passengers. Now, be careful on these. Like if this were like a written test or a written exam, something like that, something written, you wouldn't want to just write 40 on this. Like we know I put 40, dang it. I meant 18. My bad. I don't know how that went from 40 to 18, but 18. The answer is not actually 18, okay? Again, if you're doing this by hand, you just want to label it. And for us, looks like there's, we've got an A right there, but it's passengers. I feel like that's not how you spell passengers, but I also don't care enough to find out. So that's our final answer there. 18 passengers. Oh, okay, good. In my mind, there was an E right there, but good. Well, we'll keep it as an A. I definitely recommend reading these at least once or twice. At least for me, I know, even with this as much experience as I have with math, one of the main mistakes I make is just I kind of skip over the reading part. I'm not a big reader, right? Like I'd rather deal with numbers. But don't let that discourage you. Make sure you read the problem at least once so you can gain at least a good understanding of what it's asking for, and which may help you to set the problem up like we have here. This semester, Ken paid $2,324 for tuition, $383 for books, and $66 for school supplies. How much money did he spend altogether for school this semester? Well, school would indicate, or cost for school, we would be looking at tuition, books, and supplies, right? So we're gonna look at all three of these, and we'll start with tuition. Okay, tuition, which shows at $2,324. Now I don't need to label this because I know I'm gonna label my final answer, and we have to do some addition with this stuff. In addition to the tuition, we do have the books. So there we go, the books, which are showing at $383. I don't think this is an old problem, but some of you may be thinking that's cheap compared to what I thought it was. Either way, then we have supplies, right? So we got supplies here at $66. Now, we want to know how much he spent altogether, which means we need to add these values together. Now, you can stack them two at a time. You can stack all three at one time and add. The choice is really yours. I'm just going to stack all three. I don't know if this is wise or not, but I'm going to do it more, I guess, for the sake of time, I guess. And we're going to add these together, and whatever we get out of that will be our sum, which would be how much money Ken spent on school this semester, right? So I'd start with my ones place value here, and I guess I'll pull up a box this time, so it kind of helps us to focus on each place value individually. So in my ones place value, I got 4 plus 3, which is 7, and then 6 more would give us 13. Yeah, I need to carry 1 into the tens place value, right? So I need to move that box there. There's that 1 from the 13. So that's another 10. So 1 plus 2 is 3, plus 8, so 3 and 8 more fingers, that's 11. And then the 6 there at the bottom in green, 11 and 6 would make 17. And yeah, I need to carry that 1 from the 17 over into the hundreds place value. So now in the hundreds place value, I have 1 plus 3, which is 4. And then 3 more, 5, 6, 7. Boom, 7. And yeah, it did seem like we had the thousands place value from the tuition, right? And there's nothing to operate with that 2 there, so it's going to just drop as a 2. So our sum, 2,773. But once again, just make sure you have these labeled right there. So it's actually $2,773. And again, that should make sense because, yeah, we're talking about money here in terms of how much Ken paid for school this semester. So May's annual salary is $36,074, and Jen's annual salary is $41,593. How much more money does Jen make than compared to May? So since we want to know how much more Jen makes, then we got to take Jen's value or salary here, which is at $41,593. And I want to know how much more she makes. So I am comparing it to this 36,074, which I'm going to set up. And no, I haven't said what operation we're using. I really would like for you guys to think about that just for a second. I want to figure out how much more. Now, usually when we see the word more, we would say, all right, I got to add in this case, right? Now, the reason why you may be thinking add is because it would set up May's annual salary, right? You take May's value, and then you would add however much more is made, and that would give you Jen's value. So it ends up being like this, but the way that I'm setting it up, it results with subtraction, and that comes from the fact family stuff, right? Because May's value plus whatever I get from this difference would tell me what I need to add to May's value to get Jen's. All right, that's more fact family stuff, but we're going to operate with this, and that will tell us how much more Jen makes. So I would start in the ones place value, 3 minus 4. That's not big enough, so I got to borrow 1 from the 9. One of the tens from the 9, and that makes 13 minus 4, which is 9. Now to the tens place value, now it's an 8 minus 7, right? Because it's not a 9 anymore, it's an 8. We took 1 away from the 9. 8 minus 7 is 1. So that's 8 minus 7. Now 5 minus 0, anything minus 0 is itself. I think that was one of our properties that we covered. And now in the thousands place value, it's 1 minus 6, but the 1 isn't big enough, which means I need to borrow 1 from the 10,000s place value, and that drops the 4 into a 3. So that's 11,000s minus 6,000 there, which now makes that 1 big enough into an 11. 11 minus 6 is 5 again. And yeah, in the 10,000s place value, 3 minus 3, that's just going to cancel those out as a 0. But again, we don't need a 0 there to hold that place value. Just make it a blink. So that's 5,519. We go back to the problem. It's how much more money. And so we know the label on this one is dollars. So Jen makes $5,519 more than May. Lynn used her checking account to write a check for $413 to pay off her credit card bill on Monday. After the payment was processed, her checking account had a balance of $458. How much money did she have in her checking account before she paid off the bill? Okay, so checking account to write the check to pay off the credit card. Okay, so we're looking at the checking account. That's good. Now we know how much was in the account after she made the transaction, right? So what we're going to do, we don't know how much she started with, right? How much she paid, how much was in before she paid off, right? And I guess the word I'm really looking at here is before. Before she paid off the bill. Well, before, we don't know that amount, but from that amount would have been subtracted how much she paid, which in this case is the $413, right? That's how much she paid off. So that came out of her checking account. Since it came out, that's why I have subtraction there, 413. And then it equaled, that's how much was left over, which is the 458. That's how much was in her account balance after this transaction. So that's 458 there. So yeah, I'm going to have to use a fact family in order to solve this one. Okay. So it's a subtraction problem. I would take the difference, 458, and I can add this value right here, 413, which would tell me how much was in her account before she made this payment. So let's go ahead and set this up. 458 plus 413. And again, this is how much was in her account before she made this payment. So 8 plus 3 is 11. Carry the 1. 1 plus 5 is 6. Plus that 1 in red there makes 7. That's the tens place value. Now the hundreds place value, 4 plus 4, 4 and 4 more fingers is 8. So before she made the payment, she had $871. Now we are going to see some perimeter questions on the assignment, okay? Now perimeter, you just generally, when we talk about perimeter, and it may set up more of a fact family kind of thing, which in that case, we would be solving for an unknown length from around the shape, whatever the shape is. We should usually only be seeing rectangles and triangles for now, all right? But perimeter is just the distance around the shape. So to find perimeter, you just take the sum of all the outside lengths. So, you know, if we were looking at a triangle like this one, you take this length, add it to this one, and then that would be your perimeter. Right, you're just adding those together. P for perimeter. So on a problem like this one, where it says find the perimeter of this triangle, that kind of sets up the same way I had that one. We're just going to take all these lengths on the outside, 14, 21, and 24, and we're just going to add them together. So I'll write this out here first. 14, that's the one length. The other length is 21. And then that bottom length there is 24. So 3 lengths from a triangle. That's all we should get, 3 side lengths. We're going to add these together, which is going to be the perimeter. All right, so we can stack these if we need to, so get a little bit more space. I'm going to use it inside the triangle there. 14, 21, and 24. We are going to add these together for the perimeter. So red 4 plus the purple 1. I'm in the ones place value. That's 5. 5 plus the green 4 is 9. So that's our ones place value. Now the tens place value, the red 1 plus the purple 2 is 3. 3 plus the green 2 is 5. So the perimeter on this one, P, is 59. Now, usually also you'd probably be looking for units on this, inches, feet, meters, whatever. This one didn't show what the label was or what units we were dealing with, so our final answer here is just 59. If you wanted to put units, you could. But where it didn't give us the actual units, I'm just going to skip that part. All right, find the length of the rectangle pictured here if the perimeter is 68. All right, so for perimeter, remember that it's all of the side lengths added together. So while we don't know this side length here, it means we also don't know this one, okay? Ooh, this one's kind of rough if you ask me, but here's the side length we do know, 13, which also means we know it's opposite over here. This one also would be 13 units right there. Now 68, it needs to equal the 2 green sides, which is 13 and 13, added together, right? But in addition to those 2, we have 2 other values that we have to add together. Now, one of the main things that helps us in this case is that we know those 2 red values, they're the same. It's the same value, right? So we could say, all right, now 13 plus 13, those 2 green side lengths We can show the work up here. 13 plus 13 is 26. All right, so 26 plus two other values is going to be 68. Like this. Well, we just haven't seen one where we have two missing values like this. So without using like actual algebra, for me, I think it's kind of hard to explain. But what I want to do is just kind of think about if I combine these two unknown values, I'd get this one. Now, the reason why I'm doing that is because from here I can change this into a subtraction problem with the fact family, and which would help me to solve for at least that orange value right there, right? So I'd get 68 minus the 26, which would then be, again, that's just that orange value, which is two of the red values there. Okay, so yeah, we can do that math as well. 68 minus 26. So what we're going to do here, okay, is we got 42 equals something plus itself. Yeah, the identity property of addition doesn't help us. The commutative property I don't think helps. I don't really think the fact families help you. So without using division, I don't really know how to do this without using division, other than to say we're going to use guess and test, right? Now some of you would say, well, I know it'd be 20 or 20-ish, right? You'd say, well, 20 plus 20, that doesn't do us any good because it has to be the same number, right? So you say, well, maybe you try the next one up because you need the number to be bigger. 21 plus 21 does work. So I guess I'm using kind of, it's not really systematic guess and test. It's more like inferential guess and test. So this missing length here is 21 units, whatever it is. All right. Now, I know that's not very specific. It's like, well, some of you would say, I know how to divide the 42 into 2 and to get the 21. That's fine. But if you don't feel comfortable with the division right now, you may have to use some guess and test on this because we have not gone over the division. All right. This is a composite figure because it's really two rectangles that are pushed together. Now we're asking for the perimeter. The problem with the perimeter on this one is that we're missing two of the lengths, right? If you look here, we don't have this length right here, and we don't have this one right here to add to the total. All right. Now I'm going to show you how to do this. It's kind of the long way. There is a shorter way to do this when you're dealing with perimeter. If this were an area problem, then we'd be dealing with multiplication, which should be in the next unit. But for now, here's what you're going to be doing. So let's focus on finding that red side length first, okay? Now, what we get is the full length of this is 9 right there. That kind of covered up the 9. That's a 9. That green length is 9. Well, what about that green length do we know? Well, part of it is this 3 right here, right? They're parallel, which means I could move the orange over here and say this is 3 right there, which means the rest of this length right here is the red. See that? Like this red length right here is this red length, but the red and the orange make up the 9, which means that if you took the red and added the orange, which is 3, you'd get the green, which is 9. Okay, which sets up a fact family for us to solve, which would then be 9 minus 3 equals our unknown value. And 9 minus 3, yeah, we can do that one. That is 6. So this length right here is 6. Now that may seem, I hope that doesn't seem super complicated. It may though, all right? But I'm going to use exactly the same idea on this next one to find the missing length, which is purple in this case, all right? So I may have to double up on some of the colors. Sorry about that, but I hope this helps. So I'm going to take this blue length right here, right? We know that this length right here in blue is 10. And what I got is this purple length right here, right? Which is related to, let's see if I can move that. No, it won't let me. It's related to the blue one. Now, we don't know this purple length right here, okay? But it takes up that much of the blue line. What we get then is at the top, I guess I'll use green. This green right here is 2. And that's what's left right there. That's 2 right there. Okay, so in other words, the green side length of 2 from the top, I would add that to the purple side length, which I don't know, in order to get the blue side length, which is 10. So again, using a fact family for this one, and say, okay, I'm going to take the sum of that, which is 10. I'd subtract the other length, which is 2, and that will now equal the purple side length. And 10 minus 2 is 8. So the purple side length is 8. And now I have all the side lengths that make up the perimeter, which then I can add to find the actual perimeter. So I'm going to start with the green, the green and 9 here, and then kind of move clockwise around the shape until I've used up all the values. So I'd say, all right, I'd start with the 9, then I'd move to the 2, and then the 6 in red, and then the 8 in purple, and then the 3 in orange here, and then finally the 10 in blue. And yeah, we're just adding all these together in order to find the perimeter. Now, again, whether you do this 2 numbers at a time or all at once, yeah, you could say, well, I know I'd have 9 plus 2. I can do that one pretty good. That's 11, and then add the red 6, which would be 17, and then add the purple 8. 7 plus 8 is 5. Carry the 1. 1 plus 1 is 2, plus the red 3. 5 plus 3 is 8, which is 28, plus the blue 10, which is now 38. And that would be the perimeter right there. So I guess I kind of took the long way around there. But again, if you line those up by place value and got 38, it'd be the same answer either way. But yeah, the perimeter on this one is 38. Again, 38 units, but 38 will do for now. All right, the last thing I want to point out about this one, and it would work on any problem like this one, specifically when we're dealing with composite rectangles like this, is what you can do, for perimeter specifically, by the way, this would not work with area so much. But if I took this length, what we can see is that it actually equals this purple length here, and also this green length here, right? Like if I took that purple length and then moved it up, if I moved it up here, what we should be able to see is that it actually matches the red line right here, okay? So the red line really is the purple and green line put together. And what this also means is that if I took this orange side length right here and moved it over this way, along with this side length, it actually is the same as looking at this side length right here. So what that means is I don't really need to calculate the orange or the purple. I already know that the green is 9 and that the red is 10. Okay, so I can find the perimeter this way using just these 4 lengths, because by moving those out, what I've done is I've essentially created a rectangle, right? Like this is gone here and this is gone. And so I only have 4 lengths to consider in this one. So that would make our perimeter 9 plus the 10 in red, plus the other 9 in green, and then plus the final 10 there. That's the 4 sides. And when we do that, we still get the same answer as we did on that last slide, but just in a slightly different way. Okay, and don't forget to label your answers if you see that it needs to be labeled.